Alright guys, we are going to talk about completing the square in this lesson. This is another method of solving a quadratic equation. And it kind of builds on what you guys talked about in section 4.5. So for this quadratic, we see x squared minus 8x plus 16 equals 25. What I see is that 8x plus 16, those are really nice numbers that go together. So I'm going to see if it factors. Okay, and I know usually you guys are used to having it equal to 0 first. We don't need to worry about that here, because what we're trying to do is rewrite this quadratic so we can take the square root of it. And completing the square is a way to help you get your quadratic there. Okay, so let's factor it. Remember, weird smartboard, that in order to factor, I need to ask myself, do I have two numbers that multiply to be 16 and add to be negative 8? I do. I notice that negative 4 and negative 4 are the only way that I can multiply and get 16 and add to be negative 8. Well, look at that. X minus 4, can't I just write that as x minus 4 squared equals 25? And why do I want to do that? I want to do that because then I can use that method from 4.5 where we take the square root of both sides. So we have x minus 4 equals plus or minus 5. We're then going to add 4 to both sides so that we have x equals 5 plus 4, which is 9, or x equals negative 5 plus 4, which is negative 1. So our two answers here are 9 or negative 1. So what this method does, and we did not complete the square here because we already had a perfect square quadratic, and I'll review that format with you guys in the next slide. What we did is we factored it and then used our square roots method to find our answer. That's the goal of this lesson, because we want to do that. So to complete the square, let's say I have a quadratic that is not a perfect square. I would complete the square to make it fit really nicely, so I can rewrite it as the square of a binomial. Right here, this is a binomial. It's two terms squared. That's what I want. So to complete the square for this expression, notice how there is not an a value there. That's because that always should be 1. We want to add b over 2 squared to both sides. And right now that's going to look kind of like nonsense. I'll kind of explain what that means here. So here we have in example 2, we have x squared plus 16x plus c. We want to figure out a c value that's going to make it a perfect square. And in order to do that then once we do that, we're going to factor it. According to my definition, if I want to find a c value that's a perfect square, I'm first going to take that b value and split it in half. 16 in half gives me 8. My definition then tells me to take whatever I got when I took half of my b value and square it. 8 squared is 64. So that tells me in order for this expression to be a perfect square, c has to be 64. Okay? Now we need to factor it because they want an expression as the square of a binomial. Well, I can do the same method as before. I can say what two numbers will multiply to be 64 and add to be that 16. Always you guys can fall back on that. However, we can also use the perfect square pattern, and it works every time. It's kind of nice this way. Oops, this one's not equal to anything because we just want to factor it. First of all, we're going to write parentheses and the squared. If you forget the squared, then unfortunately it would be incorrect. We need that squared, and your first term is always x. Now, if you guys look here, when you factor this, you're going to notice a pattern eventually. The number that you fill in here is always whatever you get when you take half of your b value. So we took half of our b value and got 8. So I would fill in a plus 8. In the other example we did, half of our b value, we had negative 8. Half of that is negative 4. And that is what we filled into that parentheses there. Okay, so you always take whatever you get when you take half of that b value. Be very careful of your negatives here. So that would be the square of our binomial. And for this one, since that's all they want, we're done. Remember, if you need to see anything in these videos, please rewind or check in your textbook. That's where I get all of this wonderful algebra from. Alright, so now we're actually going to solve by completing the square. So we have our quadratic up there, x squared minus 12x plus 4 equal 0. First, let's check if it is a perfect square. We're going to take half of our b value, so negative 12 is our b value, cut in half, we get negative 6. Negative 6 squared is definitely not 4. So what we need to do is we want to move this 4 out of the way in order to complete that square. So in order to move it, we would subtract 4 from both sides. So we are left with x squared minus 12x, and we're going to leave a space for the correct number that will complete the square, equals negative 4. So now let's figure out what would complete the square. We already started it. So we're going to take whatever we got when we took our b value and divided by 2. We're going to take that, negative 6. We're going to remember that when you square a negative, you always end up with a positive. And we get 36. That means that 36 is the number that will complete this square. So we're going to add 36 to both sides. Now I have a perfect square, and it fits into that nice little pattern where half of my b value is what goes in those parentheses.
Please call 5152. Mrs. Milbrandt, please call 5152.
Negative 12 cut in half was negative 6. So that means in the parentheses goes negative 6. And I have to be careful. I have to make sure I add that 36 to both sides. Otherwise my equation is off balance. So negative 4 plus 36 gives me a positive 32. I'm then going to do my regular square rooting method. Now that there's nothing on either side of that squared sign, I can square root. So I get x minus 6 equals plus or minus radical 32. And before we move on, we're going to say, oh, radical 32, that's kind of big. Let's make sure that we can't simplify that a little bit. So you guys go ahead, take a second, and simplify radical 32. Obviously the correct answer will show up in just a second. But see if you can do it on your own.